Hi everyone, welcome to the second day of Data Science Conference. We hope you had fun on yesterday's talks, maybe learned something new, and are ready for the rest of the talks. After every talk, there is a short Q&A session, so feel free to ask the speakers anything during the talk in the live stream chat. First up for today, we have Pawel. In his talk, Pawel will be presenting us a hybrid model which accounts for short-term and long-term factors that impact the price of agricultural commodities. Pawel, feel free to start the second day of talk.
Okay, and now can you hear me? Hello everyone. My name is Pawel Ekk-Cierniakowski. I'm Associate Digital Advisor at Predica in data and AI, I'm especially responsible for the projects in fields of machine learning. Today, I would like to talk about agricultural commodities prices forecasting and how could we approach to modeling the prices in agriculture, and how can we move it from a data science experiment to production. So agriculture commodities are widely met by us every day in most of the products, but we don't think about them most of the time. Agricultural commodities, as other commodities, are on the financial market and on the trade market as well. So we can trade them in spot and futures. And the spot and futures is the first thing I would like to introduce. So on the agricultural market, the spot price is when we have a buyer and the seller, and the transaction is within 2 days, maximum 2 days after signing the contract. So the buyer just bring the product, for example, wheat, and the seller pay the amount for the product. In futures, we have a contract for longer time. So we buyer and seller agree for the price for specific quantity, for specific product, and for specific delivery date. My example on the product will be wheat, so that's why it's in there, and it will be from the Chicago Board of Trade. We have two main trading exchanging in the world for agricultural products, and the one is in the US, so it's the Chicago Board of Trade, and the second one is in Europe, in France, and it's MAT. So when we want to forecast the spot price, so the price that are the most current from our perspective, we can use the approach with long and short-term model. So we can create some long-time factors and short-term factors. And it goes in about futures. So in Chicago Board of Trade, we have five um, 5 months that are futures are evaluated for wheat, and this is March, May, July, September, and December. All of the prices for all of the contracts for these futures based from for approximately 2 years. So, for example, for December 2020, we started evaluate. We started trading on this financial instrument in December 2018. Of course, we can see the information on the future prices based on front months. So if we assume that the next delivery date is front month, we can create the history from the beginning of the valuation for example December 2010, and this will be front month in December for example November 2010. Another information that we can bring from the futures contract is a spread, and spread is for example front month minus front plus 1 month prices. So this futures is one of the factors that can be seen in the short term, because it's basically the information on how the market forecasts the prices of the specific product for December, for March, for May, and so on. The other factor that in short term is especially informative is weather. In agricultural case, weather is one of the most important factor on the prices, on the production, but on the demand as well. It's very important on how was the temperature, how was the snowfall, rainfall during the wheat growth, but as well during the wheat gaining and during transportation, because sometimes with huge snowfall we can have the problem to supply the products. So it would also influence prices. If it goes about whether one of the service that can bring the information about weather forecasting and actual stand on weather is Azure Maps. And from it we can gain the information about temperature, rainfall, snowfall, and wind. Of course, weather would be also good factor for long-term modeling. So we can see the correlation in the weather in the long term. But the problem is to make a good model forecasting this weather in just some weeks, and it's impossible to forecast the weather in some years. So in the long term, we should more focus on more fundamental information about prices, and the prices is determined by two factors, so supply and demand. And from the International Grains Council, we can have the information about what is the supply of wheat across the world, and what is the demand as well across the world, and what type of demand and supply is it? Because in the wheat market, we have a few types of wheat. We can have food wheat that is used, for example, for bread production. We can have feed wheat that is used for the production, the food for the animals. Industrial, so using in some industry, and seed, so that is used for the next growing of the grains, in this case wheat. Okay, so we have all this information gaining from the databases, from the APIs. We can start the analyze our data, and if it goes about analysis of the time series, it's quite straightforward in case of what should we do, and in data analysis we should see how the time series goes, especially if there's no outliers in our data. On the financial markets, which this market for futures contracts on agriculture is as well, we can have very overreactive days. So if something happens, we can have overreaction of the market, which we can see in the middle of the chart, that we have something happens, and then if we would model the data with this outliers, it would bring us to some not so good evaluation. The other thing is to see the trend in our data, whether we are mostly growing or there's another trend. We should see on seasonality. So whether in some in some months, in some years, we can see some information about higher or lower pricing. And we can see, of course, the residuals. If we started with the some data analysis, total data analysis, we can select the features for our model. In this case, we don't have a lot of features, so we can approach with some statistics. For example, correlation matrix, and we should have in mind that if we model with some features information, it would be highly correlated variables. So we should find the high correlation with our prices, and bring the variables that are not correlated among others that we already choose for the model. Another approach to feature selection is important. It's more based on machine learning approach. So we want to see which factors were the most important for the decision-based for the tree-based algorithms, and based on it decide which variable should go first, and then looking for the correlation among other variables. And the third information, when we already created the model, we can make some diagnostic on the residuals, on normal distribution on the residuals, so we can see whether our model has a good statistics approach. And we can, when we finish the modeling, we can write our forecasts into database, and based on it, creating reports. So from the business perspective, the most important information would be what is the forecasted price on a specific day, and more important dates than others would be the dates that delivery dates of the futures contract. So we can compare whether our forecast, or whether we predict that the price for specific futures will be higher or lower than the all market thing. In the reporting page, we should also show the information about what we expect from the error on the price for specific days. As data scientists, we are more familiar with, for example, root mean square error as the metric that we used for optimize our algorithms. But from a business perspective, it's not so easy to interpret. And because of it, there's two metrics that are easier to understand, and this is mean absolute percentage error and mean absolute error. So we can easily interpret it as what is the mean the mean amount of money that we're making mistakes in our model. And bringing all together, we can go through the architecture on the of this approach. So going from this experiments to production using cloud architecture. So all that APIs mostly we can integrate, we can orchestrating using Azure Data Factory to have all the information in one database. In this case, it was Azure SQL database into we integrate all the data. Based on the data, we can create some views that would be helpful for us to making exploratory data analysis, or we can just connect with Azure SQL database using Azure Databricks. And from data science perspective, Azure Databricks is the place where all of the work happens. So we make the exploratory data analysis. So we make some correlation. We make some future selection, exploratory data analysis inside Azure Databricks, and then we create a model and diagnose model inside it. After the process is final, we write our model, we save our model to make the prediction for every day, and we save it to Azure, back to Azure SQL database. Basing on Azure SQL database, we create some tabular model in Azure Analysis Services that will be used for reporting in Power BI. And of course, if we want to have these reports every day, we managing it for we were scheduling for it for daily manner. So every day the data from APIs are integrated into Azure SQL database. The model that we have saved is implemented and saving the forecasts into database, and the reports are refreshed. Of course, after all this approach, the data science work is not done. We should have in mind that data science is not just project. It's some life cycle. So if we first prepare data, build our model, and deploy model, we should control whether our model is not outdated, and it should be retrained. So we then prepare data if it's if the if our errors rising, we should again preparing data, building model, deploying it, and so on and so on. So all of the process could be also be done in Azure Databricks. So the first thing is experiments. So we can track the experiments with specific parameters in the experiment run tool. And we can assume what metric would we track. For example, for the time series for classical models such as Sarima, the Akaika is well known and well used metric. If we track our experiment, we have found the optimum parameters for our model. We can register it. So we register a specific model that is that we wanted to make into production or into staging stage for further forecast. So we can register both models, also registered short and long term model, and we can have the information which version of the model is now in the production. So which we use for our forecast. And when we have some model in the production, we can prepare another model which we will be comparing to this production. So we can have it in staging and if it will be if it will be worse than this production model, we can transit it to the archive, and if after some days we will see that this staging model is better, we can transit it into production, and this production model will go to archive, so we can see it, and we can use it if there will be some problem with new staging model. And the last thing is, of course, to serve the model. So from the Azure Databricks, we can also serve our model on the more real-time based. But in the situation that we daily implement our model, we can just serve it via code and using Azure Data Factory as this orchestrate. Okay, that's all from my side. Thank you for your attention.